Today we'll go through the 2025 highlights of the Web of Science and InCites. So a lot of things happen on these platforms in the past few months, and the objective of today's session is to go through the major developments in these platforms. Let's start with the Web of Science. So there is one element we focus on this year is the research integrity. We worked on different elements. The first one is editorial processes that we have internally at Clarivate. And we also worked on the data aspect of reproducibility. So I'll show you how it looks like in the platform. So what we have in the Web of Science, you might have heard about the Data Citation Index. It's a database, it's a collection that sits in the Web of Science. And what we do is we link the data sets, so databases, software code, anything that has been produced by researchers that is available in repositories. So here, for instance, you have an example that has been produced and mentioned by the authors of this paper. And you have the link to the materials and data shared by the authors. So the point here is to locate very quickly the data, the underlying data of a study. In terms of transparency as well, you would see the retraction data. So here for your information, we served on the working group to develop the recommended practices, what we call the NISO recommended practices, to responsibly communicate retracted research to the community. So we applied these principles within our products, like the Web of Science, and then we help users of the Web of Science to identify papers, articles of concern, so potential articles of concern. So we index retractions using data that we get from Retraction Watch, and we clearly mark retracted articles. So for example, this paper that got retracted. So this publication has been retracted by the following retraction. So there is a notice of retraction, and we give you the reasons or the reasons. So here in this case, 3 reasons: concerns issues about the data, about the third-party involvement, and update of prior notice. That's what you can see now directly in the Web of Science. On top of transparency, you will also have more information about the record, the history of the publication. Here, I mean the peer reviews. So you'll see some publications have what we call open publisher invited reviews. So these are basically peer review reports. Publishers invited peer reviews to do the peer review, to review the manuscript, and you will see the peer reviews or the reports directly at the record level. So this is as part of the open science movement, adoption of open or transparent peer review. We know that the open peer review are gaining traction, so that is quite helpful to improve research integrity and reproducibility. The goal is to obviously decrease the fraudulent peer review and also discourage authors, researchers to manipulate the peer review process. So in the Web of Science, you can locate the articles that have been reviewed via open, transparent peer review processes, and you can actually cite those peer review as well, right? So that is also available directly in the platform. A second aspect we worked on this year is the research effectiveness. So a few elements: the streamlined search and discovery, We've done a full webinar about that a few weeks ago on the enhancement of the search experience. We worked on the researcher profiles, and I will also show you the enriched data that we have now in the platform. Okay, so let me show you in terms of search and discovery. There's been a lot of developments in the past few years. 2023, the first half, we developed or released the preprint citation index. In the same year, we developed ProQuest or PQDT citation index, ProQuest dissertation and thesis citation index that covers doctoral and master dissertation and thesis. We released the grants index. So that is basically grant data connected to the publications. First half of 2025, released the policy citation index. So it's a database of policy documents. And more recently, we released the research commons database. That's a database of open metadata sources. A pretty big database now available in the Web of Science. Let me go through those databases very quickly. The preprint citation index, let me start with it. Of course, the Web of Science started as a journal index, but we expanded with more output, conference proceedings, books, and now preprints. So we launched the preprint citation index to help meet the needs of the research community. And we know the time it takes for a paper to get published. That paper might have a preprint version. And the goal is to speed up the scientific progress so you can access that literature that it has or that is available as preprints. Of course, those preprints, they come up with their own set of challenges. Typically, a preprint hasn't been peer-reviewed yet, at least the first version. And we link. So the preprint citation index is the database where in the Web of Science that links preprints from different repositories, for example, archive.org, medRxiv, bioRxiv, chemarchive, and so on. And it's pretty useful to stay up to date in your field to also evaluate the trustworthiness of preprints that haven't gone through peer review yet. Okay, so we'll link. So you'll see a preprint might have different versions. You can add the preprints to your profile. You can get alerted if there's a new preprint that is relevant to your research project. Preprints get cited. I do that myself manually when I write a paper and I find a preprint on a server that is interesting. I create a citation directly to that preprint, and we can get some metadata out of this preprint, so you can run some meta-analysis. The second database I mentioned earlier is the ProQuest dissertation and thesis. So we know that typically dissertation and thesis are not published in from a publishing perspective in journals or conference proceedings and books. And when they get published, sometimes there's only portions of the dissertation and thesis, like only a few chapters. So there are quite a lot of dissertation and thesis, 6.2 million, more than 6.2 million metadata records from PQDT in that database, covering works from more than 4,000 universities, located in more than 60 countries. The grants index, as I mentioned earlier, we created that database of grants that have been awarded with all the details of the grant. For example, here that's a grant, 2023, it has been awarded to this researcher. You get the details. That's the amount. So 151,000 plus thousand euros. You have the definition of the PI, the principal investigator, the funding agency name, the start date of the grant, and the end date of the grant. Right now, we have about 5.7 million awarded grants from more than 300 funding agencies globally. So what we've done also, so there's a well-known gap in the literature when what we call like the gray literature, like policy documents. And to bridge that gap, we integrated policy documents into the Web of Science platform. Right now, it's covering policy documents from over 500 sources. So, for example, some organizations, Hoover Institution, the IMF, the OECD. So these are the type of organizations you'll find in producing policy documents. So the goal here is to expand the content in the web within the Web of Science platform, but also to bridge the gap. So when it comes to the so-called gray literature, that literature that's very important, relevant, that is typically not published in journals, conference proceedings, and books, or even as preprints. So here we're talking about policy documents. That's also useful to demonstrate the societal impact of research. Some researchers might contribute to the development of new policies. This is something you can use to demonstrate the impact you have on society. And then last but not least, in terms of database, we have the latest addition, the Research Commons. So there is a growing demand for more journal content on the Web of Science. So we know the specificities of the core collection, but here we're focusing on journal literature from open metadata sources. And that database sits alongside the core collection in the old databases environment. So here we look at the past 10 years, and that is data that is sourced from Crossref and OpenAlex. So it contains more than 33 million records. Here, 29 million records are new. They're unique to the platform. So you'll find that in those 33 million records, some of them have already been indexed in other databases, unlike the core collection. So based on available metadata, we can say that 53% of that content is from researchers working in the Global South. And you also have an expansion of the content in social sciences, arts, humanities. So 43% of the 33 million records is in those disciplines or fields. We also worked on the researcher profiles. Right now, initially the profiles that were limited to what you have in core collection, but now you can add content from other databases, even if it's not indexed. So you'll find the distinction between index in the core collection and non-indexed. You can add preprints as well. You can add your dissertation and thesis. You'll have that was already the case before, unique research ID, detailed analytics. It's freely available, so there is a public version of that profile, and you can download your CV. Right now, we have about 35 million, more than 35 million profiles. And 91 million documents or publications have been claimed by some of these profiles. Certain type of activity you can also add in your profile is the peer review. So it's not only what you publish, but also the manuscript that you have reviewed. You can also add that type of activity in your profile. You'll see also one development we worked on is to automatically add the publications to your profile. You'll see some publications have been added automatically. based on your email address. So that is quite helpful when you want to manage your profile more easily. You'll see also that you can create alerts when a researcher is publishing something new or is cited. You can also create that on your own profile. Something that is more recent as well is the ORCID. So you have that new ORCID search and link wizard. So you can automatically import publication from Web of Science to ORCID. The way you do that, you can find profile, automatically search for profiles in the Web of Science with the researcher's name, import papers, and send feedback by sending corrections to Clarinate. So the key benefits is that you have persistent links. It's easier to manage, to maintain your profiles across systems, and keep publication lists up to date on both sides. Yeah, so that is also quite recent development. Last month, if I'm not mistaken, that happened in November. Something that has been released as well is the smart search in comparison to the advanced search. So the advanced search is the traditional search, quite useful when you want to control what's happening. So it's basically using Boolean operators, fields within the database, can create and build your query. You can search cited references, search for researchers, and search chemical structures of compounds that are used in chemical reactions. In contrast, the smart search is quite helpful to automatically recognize the entities you might be interested in. For example, a researcher name, a journal name, an institution name, and so on, or a topic. It's Boolean and semantic, so it's combining both aspects. Helps you to autocomplete when you write a keyword. It's quite helpful to correct spelling mistakes. In the smart search, you can search for documents and researchers at the same time, and it's supporting multiple languages, whereas the advanced search is working mainly on English. So let me explain the key differences. The smart search, as I just mentioned, you'll find the recognition of different entities, a semantic search, type aheads, and autocorrect. So that is quite helpful when you want to do a quick search and you want to avoid any spelling mistakes. You can search in any URL supported languages. So for example, English, of course, but Spanish, Portuguese, Chinese, Japanese, Korean, and so on. You'll find here you'll find papers and people in results, and you'll have the capability to filter or select the type of results of the query you run in your search. So do you want to view only the Boolean results, the semantic results, or a combination of both? So that is basically how the smart search works. The goal is to use AI responsibly, so you'll find those different elements as I mentioned earlier, spelling correction. So using AI capabilities to search in different languages, recognize automatically different entities like authors, topics, or institutions, and the semantic search as well. In terms of transparency, as I mentioned, you'll see you'll have the option, the choice to, when you run a search, do you want to search only for the Boolean set query? You want to use the semantic search or a combination of both? In the smart search, you also have some visualizations that you don't have in the advanced search. For example, the co-citation map. You take a publication and you're interested in which other papers, which other paper is citing this particular paper. So if you look at this paper, is co-cited by those publications. Okay, so we see here the top 10 or the top 10 most frequently co-cited papers. So we can say this paper is very often cited with this one. and this one, and so on. So it's the frequency of co-citation. The bigger the circle, the bigger the frequency of co-citation. But you can have access to the full list. You see 546 other documents are frequently cited with the paper of interest. Of course, we know, so these different types of searches, they respond to different needs. So again, I don't want to go into too much details here. I conducted a full webinar on the smart search last month. So you'll find the recording on my website, my channel. It's available online. But basically, here, smart search is ideal for users who want more intuitive experience without needing to be proficient or to master the different advanced search capabilities like Boolean operators and so on. The advanced search is essential for a precision task like systematic reviews, strategies that you want to repeat. And the introduction of smart search does not impact advanced search at all. So they are separate search experiences. And the research assistant is a powerful AI companion for researchers who need help with complex tasks like literature reviews, identifying gaps, navigating unfamiliar topics, right? So, and that is more AI generative based experience, right? So you see some key differences here in terms of flexibility, in terms of multilingual visualizations, transparency, the search modes, and so on. Okay, there's been some more search and discovery enhancements. For example, the full text access at the point of discovery. So you'll find here, you'll find get FTR smart links that helps you connect directly to the full text. Full text at the publisher level, from the publisher link with Google Scholar that has been there for quite some time. And the real-time entitlement checks make sure that researchers who use Web of Science see what they can access, right? And that is quite helpful to streamline workflows and enhance research efficiency. The profiles, you can quickly locate experts on a topic. So you do an analysis, you do a search, you run an analysis, and you analyze by profile or researcher. So I can see quickly the profile of that researcher who seems to be quite active on a topic of interest. You can also quickly locate an institution's papers. So searching on the name of the affiliation or the institution, but also on the ID. So the ROR ID is the Research on Organization Registry. Each institution has a unique ID that you can use to search for the papers of that specific institution. So you can do a deeper institution analysis. So for example, Univ Calif Davis, that is part of the California System University, that's University of California Davis, but you also see the different colleges, right? So that Department of Wildlife, Fish and Conservation Biology is part of the College of Agricultural and Environmental Sciences. Yeah, so you can do this type and conduct this type of analysis at different levels. Of course, when you analyze the output of an institution, you see the different schemas, different fields that you can use. For example, you can report these number of papers, you can break them down by SDGs, the Sustainable Development Goals from the United Nations, or by citation topic, and so on. Now let's speak about the research impact. So three main developments: the patent and policy citations, trusted indicators, and inspect analytics integration. So let me explain what we mean by that. So in terms of research impact, I mentioned already the policy citation index, which is quite helpful if you want to demonstrate societal impact, not by only in scientific publication, but for instance, policy documents. So I mentioned already, you'll find publications or policy documents from the IMF, from the OECD, from the Hoover Institution, and so on. So diverse sources, right? So the content is sourced from a wide range of institutions, think tanks, government agencies, NGOs, and so on. The policy papers, you can search them across wide area of different fields, and it's a citation index, so you find citation linking. For instance, a citation, a policy document being cited by other types of publication. Let me show you, for instance, when we use the Web of Science Citation Network, we look at one document, right? Let's say an article. That article might have been cited by policy documents. And we know that citation from a policy document is very different compared with citation from an article or a review article, from a dissertation and thesis, from a patent, and so on, right? So that's basically what we mean by citation index. We link with the scientific literature, and you can showcase that in your profile. So for instance, a researcher here, 62 documents, right? 2,899 citations. But some citations are coming from policy documents, right? Some citations are coming from patents. So you can also showcase that in your profile. I mentioned the normalized metrics that you find now at the Web of Science level, at the publication level. So for example, the paper has been cited 57 times. How high is 57? We use citation metric from InCites, and we say that in that field, compared with documents of the same type published in the same year, the expectation or the average is 26. So if we do 57 divided by 26.54, we get 2.03. So we can say that this paper got 2 times, actually more, 2.03 times more citation than the average when compared with similar documents, meaning same type, like articles with articles in the same field published in the same year. And that level of citations is placing this document in the 91 percentile. So which means this paper, when compared with similar documents, has been cited more than 91.26% of similar documents. And we can do the same with journals as well. So if we take papers published in the same journal, we don't look at the same field, we look at the same journal published in the same year, same document type. The average was 32, 57 divided by 32, that's 1.67. So it got 67% more citation than the average compared with documents published in the same journal, the same year with the same document type. So you can also, in the Web of Science, demonstrate your real-world impact. So I mentioned the citation from policy documents, but you also have citations from patents as well. Let's speak about roadmap. The roadmap for the Web of Science is the following. So 3 main focus areas: trust and integrity, collaboration and openness, innovation and impact. So what's coming in the second half of the year? Some have already been released. The research assistant, so new tasks have been released. AI-assisted search improvements. That's Smart Search, the search and link wizard for ORCID. A new collection, that's the research commons database, and citation from retracted content as well, that is now available. So what's coming in the first half of 2026? There will be some content around research integrity metadata. So the AI attribution conflict of interest statement on papers. So for instance, an author is saying that AI has been used for that purpose. You'll find that metadata, but the same with the conflict of interest as well. In terms of openness, there will be more preprints. All right, so broader set of preprints for indexation in the database. What are we also working, for those of you who've been working on correcting profiles, we're working on a system to keep profiles up to date with the capability of updating profiles in bulk rather than one by one. You will see also first half of 2026, higher quality in terms of profiles, disambiguated profiles, so less duplicate records. That is also coming. And following on the developments on the research assistant, you'll see flexible carry out end-to-end workflows across tools with integrated AI agents. Some concepts that we are exploring, the credit contributor role. So you'll find that more and more in publications where you say that author has done this, this, and that following the credit taxonomy. So that's the credit way of reporting who did what in the study, like the first draft, the conceptualization, the data, the analysis, and so on, writing the code. So we're also exploring that. Flags for journals and their reviews. That's also something that we want to integrate in the Web of Science. You have that flag already in the master journal list. Development guided by community from votes. So this is something that we keep doing. There is a Web of Science community forum where the community is suggesting new developments. We'll expand on the policy citation index. As I said earlier, right now we have about 500 sources. There will be more content to expand this database. And the Web of Science Graph API, so that's on new API that helps you explore the knowledge graph that we have in the database in the Web of Science. So basically how publications are connected together. You'll find some dashboard related to societal impact using news, policy documents, clinical trials, and we'll also optimize the search relevancy. So that's for the roadmap in the Web of Science. You'll see, we talked about the research assistant. There was a full webinar about that, and I'll share with you the presentation. Anyway, what I want to do now is I'll mention a few points for the research assistant. For those of you who haven't seen it yet, it looks like that. You can explore a topic, conduct the beginning of a literature review, find journal. You can ask questions in different languages. And it's more than a chatbot. It's based on Web of Science core collection. So everything that is generated is based on scientific literature, no risk of hallucination. It's generative and agentic AI, so you can follow different steps. You have some different task-based guidance, as I mentioned here. So those different developments have been released already in the Web of Science. So the next wave is about the AI agents. You're gonna see that more and more. So for example, here, literature review guide, topic explorer guide, final journal guide. So these are different agents that help you execute some tasks that might take some time if you had to do that yourself manually. Okay, I want to speak about InCites. I see time flies. In terms of highlights related to InCites. So InCites, as a reminder, is built on Web of Science core collection from 1980 publication data till today. And it's mainly used for two main use cases, strategic planning and benchmarking. So you want to compare different entities, but you also something more like forward looking. So you try to understand where science is going. So here we use data from the Web of Science. So metadata from the publication. Something that we keep doing is reclustering publication through their citation topic. So this is something that we do once a year. Around April, once a year, we take publication data and we look at how they've been citing each other. Based on the citation data, we look at groups of publications that have a relatively high level of similarity, and that's what we call a citation topic. If two papers are citing another one, they're closely related, we create a group, and that's what we call the citation topic. And then you have groups of groups, and then you have groups of groups of groups of papers. So you have three levels. The micro, that's the smaller group of papers. Then you have a group of groups, that's the meso level. And then you have the macro, that's basically a broader view of science. So, and that's something that we do every year. And for instance, we added 3 new micro topics. So these are new developments in science. And we map the citation topic to the United Nations Sustainable Development Goals. Okay. This year, we also added the 17th goal. So in total, there are 17 United SDGs. You'll find also more granular data to understand what's happening in terms of collaboration. So we have now what we call the Collab CNCI or the Collaboration CNCI that helps you to compare the impact of publications when they have a collaboration element. So you have different types of collaborations. So you have the domestic collaboration, and in terms of domestic, you'll find single domestic, right? So for instance, researcher from University A collaborates with someone from the same university. That's a single domestic collaboration. Then you have multiple domestic. So you have a domestic collaboration. A researcher from University A works with someone from University B, who works also with someone from University C. And these 3 universities are from the same country. So that's a domestic or multiple domestic collaboration. And then you have the international collaboration. You have bilateral. So that's someone from country 1 is working with someone from country 2, right? So you have only authors from 2 different countries in the paper. Then you have trilateral, so you have authors from 3 different countries. And quadrilateral plus, you have authors from at least 4 different countries. And we see that depending on the type of collaboration, the impact is different, right? So these indicators are quite helpful when you want to compare the performance of publications, but you want also to be more precise. When we say CNCI, we normalize through 4 indicators or 4 levels. So you have the collaboration type, as I mentioned earlier, and then the 3 others that we talked about earlier. You have the year of publication, you have the field, and you have the document type. So the 4 levels of normalization: document type, publication year, field, and collaboration type. So that is also new in InCites. And then you have also one recent development in InCites, which is called the Research Horizon Navigator. Very, very useful to do some horizon scanning, trying to understand where science is going. This is based on recent publications, 5 years or less. And the Research Horizon Navigator helps you think forward and quickly discover those topics that are emerging, that point to maybe where future discoveries, breakthroughs are likely to occur. So you can develop your own strategy for your next contribution. Quite helpful for research managers, but also for researchers if you want to do a literature review on those very recent developments. Again, I have a full webinar on this topic. And you can do those analysis in InCites. You have now this schema. So you have the previous ones, but now you can report the output of your institution or a researcher or a country against those emerging topics to try to understand your contribution against these new topics. And then you also have new ranking. So for those of you based in Europe, you have the schema for from the European Research Council, and URAP, that is used by an institute in Turkey to compare the performance of institutions. I mentioned already before in the publication, you remember for the University in California, you had the department and the college, so you can report against those different levels. So there is now a department module in InCites where you can see the hierarchy of an institution. So you'd say University of California is part of Davis is part of University California system, and that department is under that college. So you can see the different levels. Now there is also the funder report in InCites where you can report. You can easily conduct comparison between funders. You can report the performance of the publication that mention a funder as a funding agency through different perspectives. Let's speak about the roadmap, and then I'll take some questions. So here's what happened in 2025. So again, those three focus areas: trust and integrity, collaboration and openness, innovation and impact. Starting with the innovation impact, we just spoke about the research horizon navigator integration with InCites. So that's a module that sits in the platform, but you also use the schema now you can also use the schema now in InCites. We improved the affiliation department and researcher analysis. The new report being developed, it's called country report. You simply put the name of the country or the region you're interested in, and you get a report for that entity. I already talked about the schema updates, citation topics, but also Shanghai. There's a new schema for Lithuania. Indicators, the new indicators for Collab CNCI, the collaboration category normalized citation impact for domestic and international collaborations. Journal section reports that has been released as usual towards end of June, early July 2025. That is now available and also integrated directly now in InCites. And we refresh the citation topic, as I mentioned earlier. So what's happening? Better PDF reports being exported from InCites, department filters across entities, and expanded aggregated bibliometric exports from InCites. Let me speak about journal section reports very quickly. The major development this year is around retractions. Again, there was a full webinar about journal section reports back in July. You would find the recording online. Typically, what we've done, new policy regarding retractions. So we exclude citations from and to retracted records. If a publication got cited, but those citations, some of the citations are coming from retractions, we exclude those citations from the numerator in the journal impact factor calculation. And if that document has been cited, but this document that got citations got retracted, we remove the citations. Some statistics, there have been 618 titles with the journal impact factor for the first time, and 20 journals saw their journal impact factor suppressed because of citation manipulation. The new formula for the journal impact factor in the numerator, as I mentioned earlier, we exclude the citations to and from retracted publications. All right, so an example here for that journal that got cited 10 times, but 2 citations are coming either from a retracted or a citation to a retraction. We exclude these 2 citations, so the impact factor is, instead of being 10 divided by 10, it is 8 divided by 10. So the journal impact factor is not 1 anymore, it's 0.8. All right, so let me see now if there is any questions in the chat. Okay, no question in the chat. Let me see in the Q&A section. Okay, I don't see any questions in the chat. Feel free to ask any questions, if any. We still have 10 minutes or so. Any questions? Okay, I don't see any questions coming. That is fine. I will share with you today your certificate of participation, and hopefully by tomorrow I'll share with you the recording as well and the presentation. Okay, there's a question from Marwan, who's saying how to access all the features presented in this webinar. Do we need an institutional subscription, or is a regular account sufficient? So yes, so you need an institutional subscription to the Web of Science and to InCites to get the full access to all the features. Having said that, even if you don't have an institutional subscription, you can still access some of the resources like the Web of Science profile, but that is a very limited experience. Marwan, if you can specify in the chat your institution, your affiliation, perhaps I can tell you if you have access or not. If not, you can feel free to contact me. So yeah, so I don't know where it's based, which country, which city. So that's an acronym, but if you can give me the full name. Okay, great. So so that is in Tunisia, in Sousse. Yes, in Tunisia you have access through the ministry. I recommend you reach out to either the ministry, the CNAT, so Centre National Universitaire Documentation Scientifique et Technique. This is the entity managing the access, but through University of Sousse, you have access to these resources, Web of Science and InCites. So there is a question from Gabi. I would like the link for registration. I'm not sure which link. I put it in the chat. So I put it in the chat. Yeah, so as I said, Marwan, you need to contact your librarian at the University of Sousse, or you go to CNUFT. So let me put it in the chat. Yeah. Yeah, so for example, in Tunisia, there is a full access. I can put that in the, yeah, so I can put that here. Yeah, so you have different electronic resources in Tunisia, and SUS is part of the consortium, right? Yeah, so the link is a bit slow, but yeah, you can get access to them. Yeah, University of Ghana as well, you have access. You need to contact your librarian. Librarian is quite active there, so they will be able to get access. Yes, you need to access. So I'm not able to open the link, but you need to contact the CNITS. Yeah. Is JCR planning to use AI capabilities in the future? That's a good question. I don't have the roadmap for JCR, but I will need to check with the product team. Okay, so there was the question for the registration. They put the link again, right? So I put it in the chat, and I put it in the Q&A as well. There's a question from Mohammed: how to use the free Web of Sense API to collect papers? What are the limitations as well? Thank you for your present. Yeah, so there is indeed you can use some of our APIs. The free Web of Sense API, you can get access to it. It is free, but it is indeed limited. So you have the expanded one, which is a paid one. That's a full API. But if you go for the Web of Sense API Lite, you can search for some metadata, but the metadata would be limited. For instance, this is what you would get. So I can put that in the chat if you want to look at it. So this is the data that you would retrieve. The UT, that's the code of the publication, the list of authors, the keywords, document type, title, the issue number, page number, publication date, the source, the volume, the DOI, ISBN, ISSN, but you won't get like citation data. You won't have the addresses, the affiliation, the funding information, and so on. So let me put that in the chat as well if you're interested in using the free Web of Science API. All right. I don't see any other questions. Okay. All right. Thank you very much, everyone. I wish you all the best until the next webinar. Take care. Thank you very much. Thank you. Bye.